All right, we're going to do the last limacon curve, which is going to be this right here, which is known as the convex limacon. All right, now before I get to that, a couple things I just wanted to point out. The last one we're going to do is a sine. So all these ones for these limacon curves, if you have a sine, they're always symmetric to the y-axis. Now, one thing I think I put in the first video that was a little misleading, and in fact, I can't remember if I mentioned it, but the a minus b, if you have a minus b, I think I kept putting in it flips over the y-axis. That's only if it's for cosine. All right. We didn't do any ones where you had a minus b for sine, so I don't know if I mentioned that or not. But just to kind of clarify, this a minus b for cosine is where it flips over the x, or excuse me, where it flips over the y-axis. So it just flips over y-axis. I'll try to even send out maybe another document that shows all these different examples, because they only show the cosine examples. All right. But in the end, if you don't remember where it flips, when you just follow the max-min equilibrium and you get your 5 key points, you kind of should be able to figure it out. All right, the last one, the convex one, the main thing is when you do A over B, this ratio is greater than or equal to 2. All right, you can see this example, it's a cosine one, so it's symmetric to the x-axis. The last one we're going to do is sine. It's going to be symmetric to the y-axis. And I believe there's a negative in front, so it's also going to flip over the x-axis. All right, let's get to that number 4, which is 2 pages after this. All right, there it is, number 4. So first thing we notice is A is 4 and B is 2. So the ratio there is 2. So it's got to be this last case. All right, so we say A is 4, B is 2. So A over B equals 2. So we say it's this convex. Now really, it almost just kind of looks like an ellipse. I guess they use the terminology convex because the 3 other shapes we would say are concave. At a certain point, the inner loop or the heart or the dimple, it curves inside. Convex means there's no dimple to it, or it doesn't curve in or have an inner loop. All right. So really, it almost just kind of looks like an ellipse. All right, let's get to the easy part here. So period increments, they're always going to be the same for the limacons because you just have theta. There's no number before theta, so it's assumed to be 1. Increments is pi over 2. Like we get our same key point, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then I'll move to the left. You know the deal here. We get our max-min equilibrium. We always get the equilibrium first. Equilibrium is the vertical shift, which is the A value of 4. The max, we're going to add the amplitude to the equilibrium. The amplitude is the B value, which is 2. So if I add 2 to the 4, I get 6 for the max. I take away 2 from the equilibrium, so I'm going to get 2 for the minimum. All right, so for this, the only values we're going to get for R are 6, 4, and 2. So we're only going to have points on the 2nd, 4th, and 6th circles on the polar graph. All right. All right, now sine, actually when doing this, let's leave this right here. Sine always starts at the equilibrium. So the first point here is going to be 4. Now the difference is this amplitude, there's a negative in front. So it's not going to go up, it's going to go down to the minimum. So the second point is going to be 2. Then it's going to come back up to the equilibrium of 4, go to the max of 6, and then come back down to the equilibrium of 4. And that's pretty much it. Then let's graph those 5 points. Remember, the 5th point should be the same exact as the first point. All right, so if I graph 0, 4, I go to the angle 0, and then I put a dot at the 4th circle. 1, 2, 3, 4, right here. There we go. Pi over 2, 2. Here is the angle. Then we get to the second circle. It's this right here. Pi 4. We go to the angle pi. Then we go to the fourth circle. 1, 2, 3, 4. Right here. All right. A little check mark there. 3 pi over 2, 6. There's the angle. Good thing about these is the radius is positive. Remember, if the radius is negative, it would flip. So you don't have to worry about for these ones. So let's see here. 1, 2, 3, 4, 5. So it's this point right here. And then 2 pi 4, it's going to be the same as this. These are the same point. Right? This is the same location as 0. So it's this same point. All right. And then this, it's convex. So I'm not going to draw this inward at all. There's no inner loop or dimple. So again, this is I always dread this part right here. You're probably laughing as you watch it. So I'm just going to draw this kind of going around like this. All right. So last part, let's say started here. Whatever the heck that looks like, I have no idea. There we go. I think when I draw this before, a previous year, one class said it looked like an acorn. I don't know. Just make sure it's convex and that the shape doesn't cave in. It's not concave. All right, so that is the last curve right there for the limacon ones. That's the convex one because the ratio of A and B is greater than or equal to 2.